Imagine for a second that you can step outside our reality and look at three alternate universes, three completely separate realities where the basic rules of physics have been tweaked by just a fraction of a percent. Take a look at Universe A. Here, the force of gravity is slightly stronger than what we are used to. That tiny increase means that while atoms pull together, they crash and collapse inward before they can form any stable structures. Billions of years go by, and not a single star ever ignites. It is an entirely dark, empty void. Then there is Universe B. Gravity works perfectly, but the electromagnetic force is slightly too weak. Because of that, atoms refuse to stick to one another. Chemical reactions simply cannot happen. This entire universe is nothing but an endless floating cloud of gas. No water, no DNA, no life. Finally, we have Universe C. Stars are shining and rocky planets are forming, but the nuclear force inside the atoms is a bit too weak. Because of this, the physics engine of this universe maxes out at light elements like hydrogen and helium. Heavier elements like carbon, oxygen, or iron are impossible to create. Now, compare those three dead zones to our reality. We live in a universe where gravity, electromagnetism, and the nuclear forces are balanced against each other. They sit right in the exact mathematical pocket required to forge stars, build complex chemistry, and eventually stitch together the biology in your body. Physics tells us those other three universes are completely possible. If the rules varied by even a fraction, we would never exist. Against overwhelming odds of failure, our reality sits on a razor's edge of precision. This sequence shows the exact value of the fundamental constants governing our universe. How strong gravity pulls, the exact electrical charge of an electron, the mass of a photon. These are strictly fixed numbers, set perfectly down to 40 zeros after the decimal point. There is no underlying physical law saying these values had to be this specific. Yet, if you were to change even a single digit at the very end of that long sequence, the entire structure of the universe would fall apart. This leaves scientists facing a massive structural problem. With millions of ways for the math to go wrong, how did everything turn out so exactly right? Is this an unbelievable cosmic coincidence, or does this numerical precision point to a hidden design? To see just how tight these margins are, we have to look at the work being done at Cambridge University in 1953. Astronomer Fred Hoyle was trying to solve a puzzle about carbon. Carbon is the essential building block of all known life, but to make it naturally, three separate helium atoms have to collide and fuse together at exactly the same time inside the extreme heat of a star, a sequence that is incredibly unlikely to happen on its own. Hoyle calculated that the universe's total age wasn't long enough to produce the amount of carbon required for biology, unless there was a shortcut. No one had ever measured an energy level like this before. Hoyle took his math to nuclear physicist William Fowler, who went into the lab to test the prediction. After rigorous experiments, he predicted that the carbon nucleus must have a highly specific hidden energy state that naturally pulls these three helium atoms together. Fowler found exactly the energy state Hoyle had described. The measurement was exactly 7.65 mega-electron volts. If this single metric had been even slightly higher or lower, carbon would not form, oxygen would not form, and we would not be here. The exactness of this measurement rattled the scientific community. Fred Hoyle, who had always been highly skeptical of intelligent design, later admitted that the numbers were so precise it looked as though someone had deliberately tampered with the equations. But physics has a habit of finding hidden connections. In 1915, mathematician Emmy Noether proved that the universe's rules aren't just isolated random settings. They are deeply linked by mathematical symmetries. If rules remain consistent over time, for instance, the conservation of energy naturally emerges as a result. We've seen this pattern of connection before. When James Clerk Maxwell studied electricity, magnetism, and light, they all looked like entirely separate phenomena. But his equations proved they were actually the exact same thing, operating under a single unified framework, electromagnetism. So how do we explain the perfect numbers that allow us to exist? One logical explanation is the Anthropic Principle. This argues that we are only asking this question because we happen to live in a universe that supports life. If the numbers were wrong, we simply wouldn't be here to observe them. The second major explanation is the multiverse hypothesis. This suggests that our reality is just one of an infinite number of universes bubbling out in space-time. Each universe rolls the dice on its own set of physics. Most collapse or remain empty, but statistically, one of them was bound to get the winning combination. Both concepts offer a logical way out of the fine-tuning problem. The issue is that neither can be physically tested or measured. Since we cannot observe other universes, relying on them to explain our own is incredibly frustrating for physicists who require hard proof. All of this debate over perfect equations and fine-tuned laws carries a massive blind spot. Everything we have just discussed, every star, every planet, every human being, and every atom we can measure, makes up exactly 5% of the total universe. The rest is completely hidden from us. About 27% of existence is something we call dark matter. We know it is there because we can measure its gravitational pull holding spinning galaxies together, but it does not emit or absorb light. We cannot see it, and we cannot touch it. This chart breaks down the actual composition of our reality. Beyond normal matter and dark matter, the remaining 68% is dark energy. This is a completely unknown force that is actively fighting against gravity, stretching the fabric of space apart faster and faster. We spend all our time marveling at the perfection of our physics, but that awe is based on a tiny fraction of the picture. We are entirely blind to what the vast majority of our universe actually is. Right now, we rely on two primary frameworks to make sense of reality. General relativity perfectly describes massive objects, like planets and stars. Quantum mechanics perfectly describes the microscopic, like atoms and subatomic particles. The problem is, they are completely incompatible with each other. When physicists try to combine these two theories to explain extreme events, like the exact moment of the Big Bang, the equations break down entirely. The math spits out infinite variables and unsolvable errors. This is why thousands of scientists are actively hunting for a theory of everything. They are searching for the master rule that reconciles this clash and illuminates the dark 95% of the cosmos we cannot see. Ultimately, physics hasn't solved the mystery of why we exist in such a highly specific environment. It has simply evolved the question. To understand why the rules of reality are so perfectly tuned for life, we have to look past the 5% of the universe we can measure and figure out what is hiding in the dark.